In this video, we will work related rate problems. Guidelines for solving related rate problems. Step 1. Read the problem and identify and assign appropriate variables to the quantities whose values and rates of change are either known or needs to be determined. Make a sketch if possible. Step 2. Write an equation or formula that relates the quantities identified in step 1. Step 3. Differentiate both sides of the equation obtained in step 2 with respect to t using the chain rule. Then substitute the values in the equation obtained in step 3 and then solve the equation for the required rate of change. Here is an example. A point moves along the curve y equals 2x squared minus 1 in such a way that the y value is decreasing at the rate of 2 units per second. At what rate is x changing when x equals to minus 3 over 2? So let's see. We start with the equation y equals to 2x squared minus 1. Now y value is decreasing at the rate of 2 units per second. This will be translated to dy over dt equals to minus 2 units per second. What rate is x changing? That will translate to dx over dt. Now we differentiate the equation with respect to t. So y becomes dy over dt and equal d over dt of 2x squared minus 1. Then we apply the sum difference rule of differentiation. We break it down into two derivatives. 2 times d over dt of x squared minus d over dt of 1. So we will, as x is a function of t, we apply this chain rule. D over dt of x to the n equals to n times x to the n minus 1 times dx over dt. So this becomes 2 times 2x times dx over dt. But d or dt of 1 is 0 because 1 is constant. Now we have dy over dt equals to 4x times dx over dt. We know dy over dt is negative 2 and x is minus 3 halves. So we substitute this information in this equation. So now we have equation negative 2 equals to 4 times negative 3 halves times dx over dt. Now we can simplify. 4 times 3 is negative 12 and divide by 2 is negative 6 dx over dt. So now we divide by negative 6 and you will have negative 2 over negative 6, which will be 1/3 units per second. Example 2. As a balloon in the shape of square sphere is being blown up, the volume is increasing at the rate of 4 cubic inches per second. At what rate is the radius increasing when the radius is 2 inches? So if we read the problem, you will find the following. Geometric figure is sphere. Volume V is increasing. The volume V is increasing at the rate of 4 cubic per inches per second. So this will translate to d over dt equals to 4 inches cubed per second. A radius r is increasing will translate dr over dt. Now it's a volume of sphere and the formula is volume V equal to 4 over 3 pi r cubed. Now we differentiate this equation with respect to t. So V become d over dt. For 4/3 pi is just a coefficient. You just type it. The derivative of r cubed will be using this chain rule, where we 3r squared dr over dt. Now we substitute r is equal to 2 and dv over dt equals to 4. But you can also cancel 3 with 3. So you have a d over dt becomes 4, 3 cancel becomes 4 pi and r is 2. It becomes 2 square and d over dt I have to find. So now we simplify, which becomes 2 square is 4, 4 times 4 is 16 pi equals to 4. So now we divide 16 pi, so it will be 4 over 16 pi, which will be 1 over 4 pi inches per second. Example 3. A balloon rises at the rate of 8 feet per second from a point, this point, on the ground 60 feet from this observer. We have find the rate of change of the angle of elevation. This is the angle of elevation theta when the balloon is 25 feet above the ground. So let S be the height of the balloon. Distance from the observer from the point is 60 feet. A balloon rises at the rate of 8 feet per second translates to ds over dt equals to 8. A rate of change of angle of elevation theta translates to d theta over dt. And that's we have to find. So we need to write an equation. So we can use this height and this distance and this angle. We can try to relate these three quantities within a trigonometric equation. We know S is the opposite of the angle theta and 60 is adjacent, and we know opposite of adjacent is tangent theta. So therefore we have a S over 60 is tangent theta. Now we multiply 60 here and 60 here, we get S equals to 60 tangent theta. So now we have equation S equals to 60 tangent theta. So we can differentiate each side with respect to t. So this S becomes ds over dt and 60. The derivative of tangent is secant square theta, but now I have to multiply the derivative of theta with respect to t, which is d theta over dt. And we have to find d theta over dt. So secant square theta we can replace with 1 plus tangent square theta. So our equation becomes ds over dt equals to 60 times 1 plus tangent square theta d theta over dt. Now let's use the idea the balloon is 25 feet above the ground and the distance of the observer is still 60. So now we can use 25 over 60 is equal to tangent theta. So tangent theta is 25 over 60. So we can substitute this value of tangent theta in this equation and we will get. So we have equation ds over dt equal to 60 times 1 plus tangent square theta d theta over dt. But we also have a value, tangent theta is 512 and ds over dt is 8. We substitute these values in this equation this equation becomes 8 equals to 60 times 1 plus 5 over 12 squared d theta over dt. Now we just simplify, but 5 over 12 squared becomes 25, 144 plus 1 times 60 equals to 8. Now first let's add these two. Well, one I can change fraction with a denominator 144 and then become 144 or 144. Now we can add this fraction into this one. Same denominators, we can add the numerators. 144 plus 25 become 169 or 144 times 60 equals to 8. Now we need to solve for d theta over dt. So we multiply each side by 144 over 169, which means we divide by this. So, okay, so we have an equation 8 times 144, 169 equals 60 times 169, 144, and 144, 169 d theta over dt. This we can simplify and get 60 d theta over dt equals 1152 over 169. We need to isolate d theta over dt if we divide both sides with 60. So you have 1 over 60 times 1152 over 169 equal to 60 over 60. They cancel out, you get d theta over d2. This we can simplify in 96 or 845 radians per second. Example 4, baseball. A baseball diamond has the shape of a square with sides 90 feet long. 90 feet, 90 feet, 90 feet, 90 feet. A player running from the second base to the third base at a speed of 25 feet per second is 20 feet from third base. At what rate is the player's distance from home plate changing? Round your answer to decimal places. So let x equal to distance of player from the third base, and y is the distance of player from home base. Okay, so A is 90, B is equal to x, C equals to y. So we apply Pythagorean theorem, C square equals to A square plus B square. We substitute A equal to 90 and B is equal to x and C is equal to y. So we have an equation y square equals to 90 square plus x square. Now we differentiate with respect to t. So y square becomes 2y dy over dt, 90 square is 0, and x square becomes 2x dx over dt. We know x is 20 now, dx over dt is minus 25 feet because the distance is decreasing. So equation becomes 2y dy over dt equals to 2 times 20 minus 25, which is negative 1000. Now we divide by 2y. So this becomes dy over dt equals to minus 1000 over 2y. Now we can divide 1000 by 2 and you get minus 500 over y. Now we need to find y using x is 20 and a is 90. So to find y, we again apply Pythagorean theorem, c squared equals to a squared plus b squared. And now we have a is x, which is 20, b is 90, and c is y. So this equation becomes y squared equals 20 squared plus 90 squared. Now 20 squared is 400, 90 squared is 8100, total is 8500. Now take the square root and become y equals to square root 8500. Now rewrite dy over dt, which is negative 500 over y. Substitute y equal to the square root of 8500. So this becomes negative 500 over square root of 8500. Now we use the calculator, so we'll get minus 5.42 feet per second.